In this video, we're going to explore the relationship between excess capacity, product costing, and pricing. We're going to take a look specifically at the NAC Airlines example given in the textbook. The importance of managing capacity costs increase with the relative proportion of costs in an organization's cost structure. Consider Northern Air Charters, NAC, which operates a fleet of small aircraft that flies tourists into remote regions for hunting, fishing, and backpacking trips. NAC purchased planes based on an estimated long-term annual volume of 2,500 passengers. If every seat were filled on every flight, NAC could theoretically carry 4,000 passengers per year. However, under the best practical conditions, it expects the planes will carry no more than 3,200 passengers per year. That's 2,400 in the summer months and only 800 during the winter months. NAC incurs $400,000 in fixed operating costs for depreciation, supervision, and other items. NAC uses a traditional product costing system to compute product costs and allocate fixed costs based on the number of passengers flown. Zach Stryker, NAC's owner, is concerned about fluctuations in the reported product costs for the past few years, as he uses reported costs along with information on market conditions to establish trip prices. Here's our reported product cost for the last several years. In year one, NAC flew 2,000 passengers, resulting in a fixed cost per passenger of $200. In the second year, they flew 2,500 passengers. The higher level of volume reduced in a lower fixed cost per passenger of $160. In the most recent year, they only flew 1,600 passengers, resulting in a fixed cost per passenger of $250. A problem with using product cost, in particular those that include fixed cost, in helping determine prices, is that we can create a downward or death spiral. As NAC's volume of flights drops, its cost per flight increases, and if we were to raise our prices, that's likely to result in further drops in the number of passengers, which of course would result in higher fixed cost per passengers. And again, if we're using fixed costs and cost as a basis for determining prices, we would continue to raise our prices. We can examine 4 different methods for allocating fixed costs. The first is a theoretical method, in which the theoretical capacity is the capacity that could be produced or served under ideal conditions without allowing for normal maintenance and expected downtimes. A second way of allocating fixed costs is a practical method. Practical capacity is the capacity that could be produced allowing for normal maintenance and expected downtime. We can also consider a normal activity level, which is our long-run expected volume, or actual activity levels. That's the volume actually produced in a given time period, which we can see above caused big fluctuations in our fixed cost per passenger. The strongest arguments are generally made for using practical capacity or some other long-term measure of volume for allocating costs. Using normal or actual levels of activity suggests customers should pay for unused capacity. And if companies use this as a basis for setting prices, they're likely to be undercut by competitors who don't have excess capacity, lose market share, and create an ever downward spiral in market share and rising prices. Let's take a look at an example of how we might consider allocating this fixed cost of $400,000 per year for NAC. We're going to consider 4 different methods. 1, treating an excess capacity as a period cost. In other words, don't allocate it to our passengers, but rather direct it directly to the income statement. Allocate it evenly to all passengers over the entire year. Allocate the excess capacity to winter passengers, or a 4th method, allocate it to summer passengers. And again, the rationale there would be we've purchased the additional planes to handle the higher levels of volume associated with summer flights. Therefore, that excess capacity should perhaps be allocated to those summer passengers. Let's go ahead and consider how our product cost or cost per passenger would work out if we treated the cost as a period cost. Our diagram shows our costs of $400,000 for the year, $200,000 for summer passengers, labeled C in our diagram, $100,000 for winter passengers if we were to allocate it to the actual 800 passengers, and that's labeled B, and another $100,000 labeled A, which represents our excess capacity. Let's go ahead and see what happens if we treat that excess capacity as a period cost. If we treat it as a period cost, then the cost we have to allocate to winter passengers is only the direct cost of $100,000. And if we've got 800 passengers, which we would have a cost of $125 per passenger. The cost of the summer passengers, the $200,000, is allocated directly to the summer passengers, and with 1,600 passengers, we would have a cost per passenger of $125 as well. If we treat the excess capacity as a period cost and then determine prices based on our product costs, you can see we would probably end up underpricing our summer flights and perhaps overpricing our winter flights. Let's consider another alternative where we allocate the cost strictly to winter passengers. If we allocate the cost strictly to winter passengers, then the cost for serving winter passengers is $200,000 and $200,000 as well for the cost for summer passengers. Since we only have 800 passengers in the winter, the average cost per flight would be $250. And if we're basing our flight prices on costs, we would tend to raise our prices in the winter just when demand is lowest. And of course, we would have the $125,000 in the summer, which means we are probably going to offer prices that are too low. Another alternative is to allocate that excess capacity to the cost of flying summer passengers. So we would have $100,000 allocated to winter passengers, $300,000 for summer passengers, that's the $200,000 in direct cost plus the $100,000 in excess capacity, giving us a cost per passenger of $125 for winter passengers and a cost of $188 per passenger for summer passengers. This would give us probably a more of an ideal situation where we're going to have lower ticket prices in the winter and higher ticket prices in the summer. And again, that's if we're using cost as a basis for for setting our product prices. We could also consider allocating it evenly to all passengers. In other words, take the $400,000, regardless of whether they're winter or summer passengers, and spread it over the entire 2,400 passengers we expect to fly in a given year, and we would have $167 per passenger, regardless of whether it is a summer or a winter passenger. So conceptually, you can see it probably makes the most sense to think about allocating that excess capacity to the summer passengers, since we've acquired the excess capacity to serve the higher customer demand in the summer months.